Hi, my name is Shohag Rana and welcome to our presentation for cloud security relating to a financial organization. So here you can see our design specification. Whatever we did in AWS, everything is according to our design specifications. So I will be talking mainly about the VPC and everything related to VPC, such as the subnets, routing tables, internet gateways, NACLs or network access control lists, and security groups. And my other team members will talk about the SNS, API gateway, Cognito, the EC2 creation, database creation, and the other parts such as the Glacier, Shield, WAF, GuardDuty, and CloudWatch. So without any further ado, let's get started. So whenever we create any resource in AWS, at first we need VPC or virtual private cloud. So that is basically our resource space, or in our case, we defined it as 10.0.0.0/16. So this CIDR basically helps us to create a very good amount of subnets that we require for our project. For example, in this case, we created 4 different subnets, 2 public subnets and 2 private subnets. Um, Everything is according to the specification right here. So the 2 public subnets are, as you can see here, and private subnets are here. So we created these 4 subnets from this from inside the VPC, as you can see in the resource map right here. So the subnets right here are in 2 different availability zones. So 2 public subnets are in 2 availability zones. 2 private subnets are in 2 different availability zones. Why do we need this? Mainly because of disaster recovery. So if anything happens in this availability zone, the other availability zone will take over and ensure a seamless connectivity to the application or seamless connectivity to the organization. So here we can see that basically the 2 different subnets, the public subnet to A, are connected to the routing table, FinApp public routing table, which and the 2 private subnets are connected to the FinApp private routing table. These in turn are connected to the public subnet is internet facing, so it's connected to the internet gateway as we can see here. And the private subnet is connected, or the private routing table is connected to the NAT gateway. Um, this is mainly because since it's a private subnet, we don't allow direct connectivity to the resources inside the private subnet. So we do this through the NAT gateway. The NAT gateway is basically situated in a public subnet through which it can communicate to the internet. So let's get into more detail into what we did here. But before I do get into the detail, I would like to share that, yeah, I faced a lot of problems because I accidentally created 2 public subnets inside a single availability zone. So I created 2A and both of the public subnets inside 2A and both of the private subnets inside 2B. This caused problems later on, which I ultimately realized after 5 or 6 steps. So I had to restart the project. I had to restart the project like 2 times, mainly because of small issues like this. But yeah, let's get into the details of the subnets. So the subnets you can see here are the 2 public subnets that I created here. The first public subnet is 10.0.0/24. It's in availability zone 2A. The other public subnet is also is in a different availability zone 2B, and it's 10.0.10. And the private subnet is first one is in 2A 10.0.0/10.0.20, and the other one is in the other availability zone 10.0.30/24. So this is how I created the different subnets, and let's go get into the routing tables next. So the routing tables right here, you can see I have 2 routing tables. The public routing table, it has routes directly to the internet gateway since it's the public subnet, and the subnet association is obviously the 2 public subnets I defined here. Similarly, for the private routing table right here, you can see that it's connected directly to the NAT gateway, and it's the subnet association is the two private subnets, 2A and 2B. So the internet gateway is created here. This was very easy to set up, mainly because all I needed to do was create the internet gateway and attach it to our FinApp VPC. So once we did that, our internet gateway is attached to the VPC that we created. Next, I would like to show the NAT gateways right here. So the two NAT gateways right here, you can see these are basically connected. These are situated in the public subnet, as you can see here, and these basically these are a critical component of our architecture, as it allows the private subnets to access the internet for things like software updates or external API calls. It basically prevents the inbound internet traffic and protects the backend services. Uh, the backend services that are connected to the private subnet are basically the EC2 instances and the database. Yeah. So moving on, we can see the network access control list, or NACLs. So let's look into the public NACLs first. So the NACLs basically add additional layer of security to the subnet level, and it allows us to create inbound and outbound rules, which basically like filter the traffic which are allowed into the subnet. So let's go ahead and see the public subnet right here. So the inbound rules that I have allowed are basically HTTP and HTTPS from anywhere. And the other rules are basically to the communication to the private subnet. So 10.0.20 and 10.0.30 are the private subnets, and all of the ports range you can see here are allowed for the inbound traffics. And the outbound rules are basically HTTP and HTTPS to everyone. So the amazing thing for NACL is, like, by default, all other types of traffic is denied. So it's an implicit deny. So we have to set the rules for the specific traffic that we want. Yeah. So again, for the private subnet NACLs, we can see that I have given the source 802443 allowed for inbound rules, and for the outbound rules, I have allowed all types of traffic. So let's move on to the security groups. So the security groups right here, these are basically a virtual firewall for individual resources such as the EC2 instances and the RDS database. As you can see, I have named these accordingly. So it only allows necessary traffic. Again, these are basically filtering rules. The security groups are basically filtering what kind of traffic are we allowing in each instance, right? So first, let's go ahead and look into the LBSG, or the load balancer security group. So it basically allows all HTTP and HTTPS traffic from everywhere. And the outbound rules is basically it's connected. It's also all type of traffic everywhere. So this, first of all, we needed to create this security group in order to make the EC2 security group, because as you can see in our diagram, the load balancer is connected to the EC2s, and the EC2s are connected to the database. So first, so in the EC2 instances, we can see that the inbound traffic, everything is allowed, HTTP and HTTPS is allowed only from the security group of the LBSG, load balancer security group. Everything is allowed from there, the HTTP and HTTPS traffic only. And the outbound rule is to the LBSG and the DBSG. So the database security group is the one that we needed to create next. So the database security group, we can see right here, the inbound rules is from EC2SG, and the outbound rules is also to EC2SG. So this is how we can basically secure our whole application, the networking parts of our application. So this is all from me. Thank you.
Hello everyone, I'm Mohammed Dawood Hussain. Next, I will discuss the application components, including the compute, storage, messaging, and the user authentication. So let's start with the EC2 instance. So what's actually EC2 instance? Our EC2 instance hosts the application backend service isolated in private subnet to protect them from authentic internet access. These instances are the part of auto scaling group to handle the variable loads and ensuring the high availability and cost efficiency. So actually we are now moving towards the EC2 service that we have actually engaged in our system. So search with EC2. So here we can see one instance is running over there. So when we are clicking on the instance, we can see there is an instance ID and the status is currently running, and it's actually the type is D2 micro type, and all the checks are passed here, 2 out of 2. So that's about the EC2 instance. So next, moving on to the database. So initially we have used the Amazon RDS and Elastic Cache. So what the database has been used? The financial application requires the relative scale of database solutions. Amazon RDS is used for maintaining our transaction database, offering the encryptions and the rest and the transactionally. And Elastic Cache is integrated for caching the frequency access data, reducing the latency and improving the performance without compromising the data security. But unfortunately, first when we are actually using the database, so there was actually costing us a lot, so it almost cost $100 in 2 days. So sir approached us and asked us to not to spend this much of resources. So for this reason, we have to transfer to the Dynamo DB. So we have added our table to the Dynamo DB. So when we are actually going to the Dynamo DB, and here we can find the table over there. So this is our transaction table, and we are actually dealing the system with this table. So next we are actually moving on to the simple notification service, SNS. So SNS is an Amazon enable real-time notification system. So which is actually used for uh, critical alerting security, critical um, alerting to the security team with a potential evidence on it. The component integrates with the Lambda and automated alerts, enhancing the incidence of the response time. So, what is Lambda? It will be discussed a bit later, and how we have set up that. So, here we have actually enabled SNS with an email address of one of our teammate of Shohag Rana. So, if any things will hamper, that will be added to that the mail will be sent to his account. So like next we are moving on to the Lambda function. So AWS Lambda provides the serviceless computing to the automated event given task within our architecture. For instance, we use the Lambda for logging changes and sending the alerts to the SNS. So what SNS we have seen over there, and allowing us to react quickly to the system without managing the additional. So connected the Lambda. For this, we have added the code over there in the Lambda function. So it's taking a bit time for loading. So here is the code over there for actually that has been merged with the SNS system. And for this, if we find any security issue, the SNS will actually give the notification to us. So that's the SNS. So in the topics, we can see there is a EC2 event over there that has been connected with the Lambda and initiated with our system. And last but not the least is the API gateway. So here's the API gateway. We have set it over there. So what's API gateway? API gateway acts like a secure entry point to our application in the backend service. It integrates with the Cognito and handles user authentication and authorization. And it ensures the only verified user can access this application. Cognito provides identify and access management essential for the complements with the financial data regulation. So when we actually go into the API gateway, we can see here is the API of our us. And it is following the HTTP protocols, and it was created on the 4th of November, and it's actually a regional based one. And if we want to see the service of it, we can see we can get any service from this one, and we can create different gateways under these sectors as well. So that's actually from my part, and rest of the part will be discussed by my other teammates. Thank you.
Hello everyone, my name is Mirajul Islam Majumdar and now I will continue the presentation. In this final phase, we are focusing on monitoring, logging and archiving to ensure our applicants' reliability, data integrity and compliance with governance standards. This part includes configuring keys, AWS services, Amazon S3, Amazon CloudWatch, AWS CloudTrail, Amazon Guard Duty, AWS WAF, and Shield. Each plays a specific role in our architecture. Let's go over how they contribute. At first, AWS CloudWatch. The goal with CloudWatch is real-time monitoring of our AWS resources and applications. We already have set up alarms for critical metrics like CPU usage, disk I/O, and network traffic. Plus, we will create a dashboard for viewing real-time data and historical trends. CloudWatch logs already will collect and monitor log files to give us a clear picture of our system health. Here we can see that in CloudWatch. Here we can see that we have already set up two alarm, and each of the alarm we have set a timer which is less than 30 minutes. Then we have AWS CloudTrail. This service is essential for tracking activity across our AWS environment. By enabling CloudTrail, we will capture API calls and user actions, with log files automatically stored in an S3 bucket for easy archiving and analysis. Additionally, CloudTrail Insights will detect unusual activity, giving us insights into any potential risk. And we can see in the CloudTrail event history. Here we can see the event name, time, and username as well. And all this data is saved in DynamoDB, which is our main database. And one of my teammates has already talked about it. Moving forward, then there is Amazon Guard Duty for intelligent threat detection. By enabling Guard Duty, we will continuously monitor for suspicious activity and potential threats. Guard Duty findings will provide actionable insights that we can use to strengthen our security measures proactively. So here we can see on Guard Duty. We can see the summary of our guard duty, and here we can see that the total findings is 2, and in the graph we can see that the findings are low, and here we can see the access keys and account number as well. Moving forward, for protection against web-based attacks, we will use AWS WAF and AWS Shield. AWS WAF will protect us from common web exploits like SQL injections, while AWS Shield offers DDoS protections. If needed, we can use Shield Advanced for higher level of security. WAF and Shield will work with ELB or CloudFront to filter malicious traffic before it reaches our applications. Here we can see on WAF and Shield. In web ACLs, we can see that here is the name and the ID which we found. And finally, let's talk about Amazon S3 for log archiving. S3 will provide secure, cost-effective storage for logs generated by CloudTrail, CloudWatch, and other sources. We will set up lifecycle policies to move older logs to S3 standards IA or Glacier, savings on storage costs. Additionally, versioning and cross-train application will enhance data durability and availability. In Amazon S3 we can see that here we can see the buckets, and here's the we can also see the name, AWS region, access analyzer, and creation time data as well. So, in conclusion, with these configurations in place, we have a powerful setup to monitor our application, archive logs effectively, and mitigate security threats. This phase of the architecture doesn't just meet best practices for security and compliances, it also enhances our availability to respond to operational issues quickly. Together, this service provides us with a comprehensive view of our system's health by protecting our data integrity and security at every level. Thank you, everyone. That's all.